Hello, dear student. Welcome to you. I am Rajiv Kumar Sa. Now we are going to learn a very important topic, potentiometer from the chapter current electricity. This is most frequently asked topic in NEET and JEE. Okay, so let's discuss potentiometer. So name suggests that this instrument is used to measure potential difference. Okay, so we know that voltmeter is also used to measure potential difference between 2 points. But voltmeter does not give correct value because voltmeter draws some current from the circuit. That is why voltmeter always give potential difference between 2 points is less than actual potential. Okay, so potentiometer, it is an electrical measuring instrument. It is an electrical measuring instrument which used to measure potential difference between 2 points accurately without drawing any current from the circuit, right? Okay, so potentiometer is also used to measure EMF of the cell. It measured EMF of the cell. Okay, it compared the EMF of the cell. Also measure the internal resistance of the cell. It is also measured internal resistance of the cell. Okay, internal resistance of the cell. So we can find the internal resistance of the cell by potentiometer. So potentiometer is nothing but a very long wire fitted on wooden platform. Okay, so now we'll see the principle of potentiometer. Principle of potentiometer. So potentiometer consists of a very long wire. So let us take one very long wire. Long metal wire. Now let's take current I is flowing and here A is uniform. Cross section area of this wire is uniform. Now length of the wire is L. L is length of the wire and rho is resistivity of the metal. Resistivity. So we know that resistivity for each metal is different. For copper it is different, for aluminum it is different, for silver it is different. So for given metal resistivity is fixed. Okay, so rho is resistivity. Now we know that current is always flowing from higher potential to lower potential. So this is higher potential and this is lower potential. Okay, so let's consider here potential is V1 and here potential is V2. So now potential difference V1 minus V2 is equal to, here current I is flowing, I is constant current is flowing and R is resistance of the wire. So I, and resistance is nothing but rho L by A. Okay, so potential difference we can write as V. Now I rho by A. Current is constant, current is constant here. Resistivity is fixed because it is fixed for a given metal, and A is area is uniform for the given length of the wire. Now into L. So K is I rho by A. Okay, so V we can write K times of L, and this K is nothing but V by L, and this is potential per unit length. SI unit is volt per meter. Okay, so this K is known as potential gradient. Potential gradient. Potential per unit length is known as potential gradient. Okay, so principle of potentiometer states that for a given length of the wire, potential difference between the 2 points is directly proportional to its length. Okay, potential difference between any 2 points is directly proportional to length between 2 points. If length is more, then potential drop will be more. If length is less, then potential difference will be less. So V is equal to K times L. Yeah, V directly proportional to L. Okay, here K is potential gradient. Now let's see the circuit diagram of potentiometer. So potentiometer consists of one battery and here one ammeter, rheostat. Rheostat is nothing but a variable resistance, one key, here length of the potentiometer wire is AV. This is battery of EMF A. This is rheostat and this is key. Okay, now here point P and here one jockey. This is jockey, and jockey is connected in series with the galvanometer, and here Q. So any external element where potential is used to measure is connected between the 2 points. External element where we need to find potential difference connected between point P and Q, between point PQ. Okay. So how will you measure the potential difference between 2 points? Yeah, suppose we have to find the EMF of the cell, so we need to connect the cell between these 2 points P and Q, and we have to slide the jockey and we need to check the null point. So null point is the point where galvanometer will show no deflection, means zero deflection. So null point method. So null point is the point it is the point where galvanometer will show no deflection. Means galvanometer current is 0. So under null point condition, galvanometer current is 0. So we can say that potential difference between P and Q is equal to potential difference between A and J. So suppose null point is obtained at length L. Okay. So we can say that potential between point P and Q is equal to potential difference between potential drop occurs between A and J. Okay. So now we can say that potential drop occurs across AJ is equal to K times L, because here we got null point at length L. Okay, and this K is potential gradient, potential per unit length. For unit length, potential is K. Okay, so VPQ is equal to VAJ, which is equal to KL. Okay, but we will get no any null point when we reverse the cell. So to obtain the null point, we have to connect this side as positive terminal of the cell. Okay, so positive terminal of the cell is connected to positive terminal of the potentiometer battery, this potentiometer battery. Okay, now let's solve this question. So here question is given: a potentiometer wire of length L and resistance small r connected in series with a battery of EMF E0 and resistance R1. Okay, an unknown EMF E is balanced at a length L of the potentiometer wire, the EMF will be. Okay, so let's solve this question. So question is given here: a potentiometer wire of length capital L, here length L is given and resistance R is given, connected in series with a battery of EMF E0. So here battery is connected of EMF E0, okay, and resistance R1. So this is potentiometer wire. So length of the potentiometer wire here is L and its resistance is small r, right? Now we have to find the EMF of the cell. So we know that positive terminal of the EMF is connected to this cell, positive terminal of the given cell. Okay, now here one galvanometer is connected and here jockey, and it is given null point is obtained at length L. Okay, now to find the solution of the given question, first we need to find the potential gradient. Okay, so how will you find the potential gradient? So potential gradient, first we know that potential gradient is VAB by length. So VAB we need to find. So VAB is equal to, suppose we have to find I into here resistance of the AB wire. Okay, so let's find the current in the given circuit, which is potentiometer current. So potentiometer current is E0 by here resistance R1, and this resistance is small r, so R1 plus R. Okay, so here we will get VAB is equal to E0 times R1 plus R, and the resistance of the wire is R. So this is potential difference between point A and B. Okay, now potential gradient is VAB by L. L is length of the potentiometer wire. So VAB is equal to E naught R by R1 plus R and whole divided by L. So this is potential gradient. Now, so here it is given null point is obtained at length small l. Okay, so we will get now, suppose here P Q, so EMF of the cell which is given E. So we have to find the EMF of the cell. So E is equal to potential drop occurs between VAJ, jockey is balanced at length L. Okay, so here this will be equal to K times length L. So what is the value of K? So K is nothing but E naught R by R1 plus R into L multiplied with L. So EMF of the cell now is E naught into R L by R1 plus R divided by L. This question we are asked in NEET examination. Okay, so answer of this question is this one. Okay, so option 1 is correct. Now we'll see other question. So your question is given: a battery of EMF 4 volt is connected across 10 meter long potentiometer wire having resistance per unit length 1.6 ohm per meter. A cell of EMF 2.4 volt is connected so that its negative terminal is connected to low potential end of the potentiometer wire and other end is connected through a galvanometer to sliding contact along the wire. Okay, it is found that no deflection point occurs against the balancing length of 8 meter. Calculate the internal resistance of the 4 volt battery. Okay, so now let's solve this question. So here it is given a battery of EMF 4 volt. Okay, and we have to find the internal resistance of 4 volt battery. So let's take internal resistance of battery is R, and now the length of the potentiometer wire is given 10 meter, right? So here it is given 10 meter length is given 10 meter. Now a cell of EMF 2.4 volt is connected so that its negative terminal is connected. So this is high potential end and this is low potential. So negative terminal of the cell is connected to low potential end. Okay, and other terminal is connected with galvanometer. Right, it is found that no deflection occurs at the point balancing length 8 meter. So at this point balancing length occur, means null point is obtained. Okay, and here it is given 2.4 volt. Now we'll have to find the internal resistance of the cell. Okay, so let's calculate the answer for the given question. So here it is given resistance per unit length is 1.6 ohm per meter. Okay, so here resistance per unit length is equal to 1.6 ohm per meter and total length is 10 meter. So we can say that resistance AB is equal to 1.6 into 10. So this will be equal to 16 ohm. So resistance AB is equal to 16 ohm. Right, now find the current in the given circuit. So I is equal to 4 by total resistance. So here resistance is small r, and plus total resistance of AV is 16. So current is 4 by R plus 16. This is potentiometer current. Now we have to find the potential difference of the wire between the point A and B. So potential difference is nothing but I times RAV, resistance of potentiometer wire. Okay, so I is 4 by R plus 16. Okay, and now resistance of potentiometer wire is how much? It is equal to 16. So here 64 by R plus 16, right? Now, so here it is given balance point is obtained at this point. Okay, so we can now write as, let's take this point as C. So now we can say that this potential of cell is 2.4 volt is equal to k times this length. Okay, so EMF of the cell is equal to k times the balancing length, and k is nothing but VAB by L, length of the potentiometer wire, into balancing null point length is 8. Okay, null point length is 8. So at 8 meter from lower potential, null point is obtained, it is given. So EMF of the cell is given 2.4, right? Now VAB is 64 by R plus 16, right? And now length of the potentiometer wire is given, total length is given 10 meter. So this is total length which is given 10 meter. So divided by 10 into 8. Now cross multiply 10 this side. So it will be equal to 24 is equal to 64 by R plus 16 into 8. So here 3. So R plus 16 is equal to 64 by 3, right? So R is equal to 64 by 3 minus 16. So 64 minus 48 by 3. So here internal resistance of the cell we got 16 by 3 ohm. Okay, so hope this is clear to you. Okay, so internal resistance of the cell is 16 by 3 ohm. Now we'll see the next point, comparison of EMF of the cell. Comparison of EMF of the cell. So let's draw the diagram. So here this is driving circuit. So this is battery of EMF E which drive the potentiometer. Now ammeter is connected in series with it. Rheostat, one key is connected, and here this is potentiometer wire, and suppose EMF here E1, here EMF E2, here key, galvanometer, here k1 key is k1 and here key is k2. Okay, sorry. So here take one key k1 and here you can take key k2. Okay, this is switch, and here one galvanometer is connected, and this from this galvanometer jockey is connected. Okay, now here EMF E1, here EMF E2. Now when switch K1 is closed and K2 is open, now let's take the condition when K1 is closed, this switch first one is closed and K2 is open. Okay, so when K1 is closed and K2 is open, in that condition suppose null point is obtained at length L1. Okay, now in other condition when K1 is open and K2 is closed, so suppose null point is obtained at the length L2. Okay, so now we'll compare the EMF of that two cell. Okay, so now when K1 is closed and K2 is open, then null point is obtained at L1. Now so here A, here B, let's take this point is C and here D. So we can say that E1 is equal to K times of L1. Okay, now when K1 is open and K2 is closed, in that case the null point is obtained at L2. Then null point is obtained at L2. So we can say that E2 is equal to potential gradient times L2. So now dividing equation 1 and 2 will get L1 by L2. E1 by E2 is equal to L1 by L2. Okay. So any three known is given, we can find the fourth unknown. Okay, so suppose EMF is given, length L1 and L2 is given, so we can find the EMF of the other cell. Okay, so by using this equation we can find the EMF of unknown cell. Okay, thank you.